Hello and welcome. This is going to be our lecture video for September 23rd through 24th. We're going to be talking about area and perimeter again today, but with a twist. We're now going to start incorporating variables into the side lengths, and that's going to give us lots of great applications for combining like terms and distribution. But first, I've got another thing for you to estimate. This time, estimate how long in feet is a 72-passenger standard school bus. These are the kinds of school buses that bring students to Mountain Vista. How many feet long do you think that is? Okay, the correct answer is 34 feet. The way I like to think about this is maybe picture how many times I could lie down next to the school bus, and I know I'm about 6 feet tall. Maybe if I could fit about 6 of me in there, that helps me get an answer, so I'm not just taking a wild guess. Okay, I do think estimation is an important math skill, so we're going to keep practicing this whenever I can find it appropriate to put this in as a do now. I'll have you just keep estimating things, and hopefully you keep learning from your answers and getting better. Okay, objective for today is to find the perimeter and area of shapes with variables in their side lengths. Why are we doing this? To use combining like terms and distribution in a practical application. So we're asked, what is the perimeter of this shape? If you haven't gotten your notes out yet, pause the video, get your notes, write today's date, draw this shape. Now, how are we going to find its perimeter? Normally, the perimeter is the distance around a shape, but here, those distances are given with expressions including the variable x. So all we need to do is write an expression for the perimeter and make sure it's fully simplified. So when I find perimeter, I normally like to draw a dot at the corner I'm going to start at, and then I'm going to go clockwise around until I get back to that dot. So adding as I go, I start by walking along this side, that's x long, then I turn and go this way, that's x plus 4 long, so I say plus x plus 4, then I turn one more time and come back home, that's x plus 6 long, so I say plus x plus 6. All right, here's an expression for my perimeter, but it's not simplified. In order to simplify it, I want to bring all the x's together. There's 3 x's, so I can just write that as 3x plus 4 plus 6. Now I'll combine my constants, and I want them to be at the end. I always want the constants at the end. So 3x plus 10, and this is perimeter, so it's a length, so we'll just say units. 3x plus 10 units. Once we figure out what x is, we can just plug it into this simplified expression and figure out the perimeter much quicker. Okay, I got a couple more of these. What's the perimeter of this shape? Well, this is a rectangle, and we are assured that it's a rectangle because we can see the right angle measures. That means that even though these two sides aren't labeled, we can now go ahead and label them because the rule is in a rectangle, the opposite sides have the same length. So if this is an n over here, then this must be an n over here. If this is an n plus 2, then this must be an n plus 2. And for the perimeter, we're going to add up all those lengths. Put a big bold dot at the side you're starting from, go around clockwise. We're going to get n plus 2 plus, I'm over to here, n plus 2. All right, let's combine our like terms. This time maybe I'll cross them out as I combine them. So 1, 2, 3, 4 n's. And the 2 and the 2 come together and they become a 4. And then all we have to say is units because it's a length. All right, next one. Again, pause it, copy it down. Let's find the perimeter of this somewhat stretched out hexagon. So got to pick a point to be my original point. Be right there. And let's write this out. We got w minus 2 plus w minus 2 plus w plus 5 plus w minus 2 plus w minus 2 plus w plus 5. All right, I can see I've got 4 minus 2s. Let me just check that I've got all those. 1, 2, 3, 4. I've got 2 5s. 1, 2, and then I've got 6 w's. I can count them up. Yep, they're all there. That's a good way to make sure I've got everything. Now let's combine like terms. Like I said, I've got 6 w's. So 1, 2, 3, 4, 5, 6. So 6w A negative 2 and a negative 2 is negative 4. Plus 5, we're up to positive 1. Well, here, how about I'll combine all the negative 2's, and that's going to be a negative 8. And the 2 5's, so there's 4 negative 2, so that's negative 8. The 2 5's, those will become a 10. So I'll do this with one more step to make it a little bit more clear where these numbers are coming from. Now this becomes 6w plus 2 units. Again, it's a perimeter, so we got to say units. All right, and isn't that a whole lot simpler than this very long expression here? Okay. Another perimeter. Now we've got a second variable. We have 4a and 2b. Let's use our rule about rectangles to bring the 2b over here. And the 4a comes down here. Now I add up the 4 side lengths. Let's make a point and go clockwise from there. 2b plus 4a plus 2b plus 4a. So in order to combine terms, they have to have the same variable. So the 2b and the 2b can combine, the 4a and the 4a can combine, but they can't combine with each other. 4a and 4a makes an 8a, 2b and 2b makes a 4b. Notice I just add the coefficients and leave the variable alone, and I'll say units. All right, so we have to have 2 terms in our final perimeter here. Did I want to say anything else about this? Oh, just that I want alphabetical order with my terms. Okay, here's a really tough one. So again, pause and sketch this down. Now let's see if we can find this perimeter. All right, so here's where I'll put my point. I've got 4x plus 3y plus x plus 2y plus 3x plus 5y. All right, let's combine all the terms with x's. I'll cross them out as I go. So 4x plus x is 5x plus 3x is 8x. 3y, I'm up to 10y, or I'm up, well, 3, 5, 10 plus 10y. Alphabetic order, and it's a perimeter, so we'll say units at the end. If you want a challenge, come back to this problem at the end and try to find its area. Quite a bit trickier. Okay, and speaking of area, here we've got a rectangle, variable in one of the side lengths. We want to find the area. Let's remind ourselves real quick that area is length times width, and all that matters about length and width is that they meet in a right angle. We can assume that that's a right angle. When I multiply these though, it is super important. First, I got to designate a length and a width. I'll say this is the length, this is the width. But it's super important that I keep anything with multiple terms in a set of parentheses. So here, our area is 8 times, in parentheses, 10 plus x. The 10 plus x has to stay together. And that's super important because now we have to distribute that 8. So now we get 80 plus 8x. And then I want my constant at the end, so I just rearrange this around. 8x plus 80. And then I say units squared because it's an area. So here we have a very practical application of distribution. We're trying to find this area. We know that this is exactly 8 units long, but we know that this is 10 units plus some amount x that we're not sure about. We can even add in a little line here. So we're 10 here, and then it's x here. Well, we don't have to wait until we can measure this x. We can still do things like express the area, and then when we finally figure out what x is, we just plug it into the simplified expression and much more quickly find the true area. All right, here we've got 2 sides. They're measured both with x's. So here we could say these 2 sides are proportional. This side is 5x to this 3x. We don't know what x is, but it's going to be a 5:3 ratio of these side lengths regardless. So writing lengths with variables can help keep things proportional. But okay, let's figure out length times width. Length times width. These meet at a right angle. I'll say this is length, this is width. Doesn't matter which way you do it. Becomes 3x times 5x for the area. Now, can this be simplified? Well, it can, because between the 3 and the x is times, between the 5 and the x is times, so I can rearrange this as 3 times 5 times x times x. The 3 times 5 becomes a 15, and the x times x becomes an x squared, and we get a final answer of 15x squared units squared. All right, so that's where exponents can come from in these problems. Here we've got another one. I'm going to designate this side the length, this the width. That way I'm distributing the 7 into this from the left-hand side. Makes it maybe just a little bit easier. So 7 times, I just use a parentheses for times, 4x plus 2. Distribute in the 7. We get 28x plus 14 units squared. Okay, and here's our very last one. I want the area and the perimeter. It's a really tricky shape. So take your time drawing it, and then unpause the video, and we're going to find the area and the perimeter. Okay, so this is a composite shape, so I need to cut it up into smaller pieces. That's going to help me find both side lengths and ultimately the areas. So I'm going to put one dotted line in right here. That cuts off a rectangle at the top. I'll put in another dotted line here, and that cuts the remaining shape into 2 more rectangles. Now let's fill in what we can. If this side is 2x, then this side must be 2x. And if this side is 2x plus 1, then this must be 2x plus 1. If this is x, then this must be x. If this is 2x plus 3, then this must be 2x plus 3. And let's see, we don't have everything all the way around because we're missing this little piece right here. We're going to say that this is a continuous line here, so this also has to be x, because what's opposite of this? We could cut off another rectangle right there. Yeah, maybe I'll go ahead and do that. There's nothing that says I can't cut it into more rectangles. All that matters is that I'm left with only rectangles. So now I can more clearly see why that's an x. Okay, and now pick a point to start. I always pick bottom left corner and then add up all the way around. We have x plus x. So I've done that side, plus 2x plus 1 plus x plus 2x plus, I'm up to here, 2x plus 3 plus 2x plus 2x plus 1, and down to here, plus x plus 2x plus 3. Okay, let's start combining like terms. Crossing as I go, so I'm at x, 2x, 4x, 5x, 7x, 9x, 11, 13, 14, 16x, plus 1, 4, 5, 8. And that's a length, so we'll just say units. We'll label this the perimeter. 16x plus 8, much simpler than this very long expression here. All right, now we've got to find the area. This is extra tricky because we've got lots of x's and everything. We'll just have to write them out individually. So this one right here is going to be a 2x times 2x plus 3. This right here is a 2x plus 3 times a 2x plus 1. I'll show you how to simplify that. You won't be able to test on that. That's a really hard one. This one here is going to be x times 2x plus 3. And this final area here is x times 2x plus 1. Okay, let's start writing these out. Starting with this top one, I've got to distribute that 2x, and I'm going to get a 4x squared plus 6x. Okay, next one is this. This I have to use a technique called foiling, where you multiply the first terms, the outside terms, the inside terms, then the last terms. You're not going to be tested on this, so I'll just do it for you. That'll become a 4x squared plus 2x plus 6x plus 3. All right, now I'm up to this one. Now I gotta distribute this x. I'm gonna get a 2x squared plus 3x, and I'll distribute the x here. That gives me a 2x squared plus x. Time to combine like terms in this very massive expression, so cross outs can be very helpful. First, I'll go for all my x squared terms, because for things to be like terms, they have to match in variable and exponent, so I can only combine x squareds with other x squareds. So that's 4x squared, 8x squared, 10x squared, 12x squared. Now I can combine my x's. 6x, 8x, 14x, 17x, 18x, plus 18x. Now combine the constants. Just the 3 is the only spot where we have a constant. Yep, so it's just plus 3. And then we can say units squared for our area. Okay, that was a very tough problem. Don't stress if you got a little confused there. Nothing that hard coming up on your next test, but I figured I'd show it to you anyway, just as kind of a fun problem. All right, I'll embed a few more for you to try here, and have a good rest of your day.